Take a deep breath and allow your shoulders to drop, feeling the weight of your body sink into the soft support of your bed. As you exhale, let the tension leave your limbs, moving from your forehead down to your toes. As we prepare to drift away from the familiar world and into the silent reaches of the cosmos, we are traveling now, far beyond our solar system, to a destination 41 light-years away in the constellation of Cancer. Here, orbiting a sun-like star known as Copernicus, or 55 Cancri A, lies a world of extreme beauty and geological wonder, the exoplanet 55 Cancri E, often called Janssen. What is fascinating about this world is its sheer scale. It is a super-Earth, possessing a diameter roughly twice that of our home planet, and a mass 8 times greater. As we approach, you might feel a sense of immense stability, a heavy, grounding presence that comes from such a dense and massive body. This world is not made of soft gases or frozen ice, but of rock, metal, and, most remarkably, a heart of pure carbon. As we settle into the orbit of Janssen, the first thing you notice is the profound, radiating warmth. This planet exists in a state of eternal embrace with its star, orbiting so closely, just 1/65th the distance between Earth and our Sun, that its year lasts a mere 17 hours and 41 minutes. Imagine a world where the seasons pass in the time it takes for a single night's sleep. Because it is so close to the stellar fires of Copernicus, Janssen is tidally locked, meaning one side of the planet is forever turned toward the sun in a state of perpetual noon, while the other remains in a blanket of eternal night. We are descending now toward the day side, where the temperatures reach a staggering 2,400 degrees Celsius, or about 4,350 degrees Fahrenheit. Here's something most people don't know. At these temperatures, the very crust of the planet does not remain solid. It melts into a global, shimmering ocean of lava. This is not the jagged, explosive lava of a terrestrial volcano, but a vast, tranquil sea of molten stone that stretches from horizon to horizon. The texture of this ocean is thick and viscous, much like the consistency of warm honey or molasses. As you observe the surface, you see slow, rhythmic pulses of heat rising from the depths, creating soft, glowing ripples that catch the light of the nearby star. The atmosphere here is a thin, shimmering veil of mineral vapors. Scientific observations from the Spitzer Space Telescope suggest that the air is rich in ingredients we usually think of as solid ground silicates, calcium, and even aluminum. These minerals have been vaporized by the intense heat, forming a literal rock vapor atmosphere. What's fascinating is how these vapors behave. As they rise into the cooler upper layers of the sky, they condense, creating clouds made of sparkling mineral dust. Imagine looking up to see clouds that shimmer like powdered glass, reflecting the brilliant light of a sun that never sets. As we hover just above the molten surface, the soundscape is one of deep, resonant humming. It is the sound of a planet breathing through its geological pores. You might hear the occasional low-frequency thrum of a massive convection current moving beneath the lava, a sound so deep you feel it in your chest rather than hear it with your ears. There is no wind here in the way we understand it on Earth, but rather a slow, heavy migration of heat. Because of the planet's thick atmosphere and extreme temperatures, researchers have found that the hot spot, the point of maximum heat, is actually shifted away from the point directly beneath the star. This suggests that the atmosphere is circulating, carrying the warmth around the planet in a slow, deliberate crawl. The light on the day side of 55 Cancri E is unlike anything in our solar system. The star Copernicus is a G-type star, similar to our sun but slightly cooler and more orange in hue. From the surface of the lava ocean, the star appears enormous, filling a significant portion of the sky. The light it casts is a deep, saturated gold, which reflects off the obsidian dark lava, turning the waves into ribbons of liquid amber and molten bronze. There is a profound sense of stillness here, despite the heat. The lava moves with a slow, heavy grace, its surface tension creating smooth, rounded shapes that look like polished, dark marble. Beneath this ocean of fire lies perhaps the most extraordinary fact about 55 Cancri e, its internal composition. Based on the planet's mass and radius, astronomers like Niku Madhusudhan have proposed that at least a third of the planet's mass is made of carbon. Under the immense pressure of the planet's interior, this carbon is likely squeezed into a layer of diamond thousands of miles thick. As you visualize the world beneath the lava, imagine a crust of graphite giving way to a core of pure, crystalline diamond. It is a world of unimaginable value and structural perfection, a silent, glittering heart beating beneath a sea of fire. The sensory experience of being near this diamond world is one of intense, dry warmth. It is the kind of heat that relaxes the muscles completely, a deep tissue warmth that permeates every fiber of your being. The air doesn't feel thin, it feels substantial, heavy with the weight of vaporized stone. You can almost smell the scent of the mineral clouds, a sharp, metallic tang, like the smell of a blacksmith's forge or the scent of rain hitting hot pavement, but magnified and purified. It is the smell of the primordial universe, the scent of planets being forged in the cosmic kiln. Interestingly, the lava itself is likely silicate-based, similar to the basaltic lavas found in Hawaii. But under the unique chemistry of 55 Cancri e, it may contain high concentrations of carbon-based molecules. This gives the lava a unique optical property. It is exceptionally dark, absorbing much of the light that hits it, yet glowing from within with its own thermal radiation. You are looking at a sea that is both blacker than ink and brighter than a forge. The contrast is mesmerizing. The dark, glassy surface broken by cracks of brilliant, electric orange, where the hotter interior peek through. As we drift further across the hemisphere, we notice the shorelines, where the lava ocean begins to meet the transition zone, often called the terminator line. Here, the temperature begins a very gradual descent. While the day side is a liquid inferno, the night side of Janssen is estimated to be around 1,100 degrees Celsius. While still incredibly hot by Earth standards, this temperature allows the rock to solidify. What's fascinating is that the transition isn't an edge, but a gradient. You can see the lava beginning to thicken, the ripples moving more slowly until they freeze into place, creating a landscape of smooth, undulating glass. This glass, a form of planetary scale obsidian, is the result of the lava cooling rapidly as it moves toward the shadow side. The texture here changes from the fluid, rhythmic motion of the ocean to a static, crystalline silence. The surface is so smooth it acts as a dark mirror, reflecting the distant stars of the Cancer constellation. You might feel a sense of profound calm as we move toward this darker half of the world, leaving the roar of the stellar furnace behind for a more muted, shadowed existence. Even in the darkness of the night side, the planet is alive with heat. Scientists believe that because the atmosphere is so thick, it may trap some of the heat from the day side, preventing the night side from ever becoming truly cold. This creates a global equilibrium, a constant, circulating warmth that ensures the planet never knows the bite of frost. It is a world of constant, unchanging temperature, a steady, reliable warmth that mimics the feeling of being tucked safely into a warm bed. We must also consider the gravity of this world. Because Janssen is so much more massive than Earth, the gravity is roughly twice as strong. If you were standing on the solidified obsidian of the night side, you would feel a deep sense of being anchored to the ground. Every movement would feel deliberate and heavy. This increased gravity also affects the weather. Any mineral rain that falls from the silicate clouds would fall slowly, but with great force, the droplets of liquid rock or metal hitting the surface with a rhythmic, percussive sound. It is a metallic lullaby, a steady tink, tink, tink of cooling minerals returning to the earth from which they rose. The scale of time on 55 Cancri E is another of its wonders. Because the planet is so old, estimated to be around 8 billion years old, nearly twice the age of our Sun, it has existed in this state of molten balance for eons. The lava oceans have been rising and falling, the diamond core has been pressing and hardening, and the silicate clouds have been raining down for billions of years before our own world was even a cloud of dust. There is a deep, geological peace in this kind of longevity. It reminds us that the universe moves in cycles far longer than a human life, or even the life of a species. As we continue our observation, we notice the way the light of the star Copernicus catches the edge of the planet's atmosphere. Because the atmosphere is thick with mineral dust, it creates a magnificent halo effect, a ring of refracted light that glows with the colors of a sunset that never ends. The reds, oranges, and deep purples of the star's light are scattered by the particles of calcium and aluminum, creating a shimmering crown around the dark silhouette of the planet. This is a world of transformation, where rock becomes gas, and gas becomes rain, and carbon becomes diamond. It is a place where the basic elements of the universe are put under such pressure and heat that they reveal their most beautiful forms. As you drift deeper into relaxation, imagine yourself floating above this sea of amber light, feeling the steady, heavy pull of the diamond world beneath you. The warmth is absolute. The rhythm of the lava is the rhythm of a heartbeat, slow, steady, and eternal. In the next stage of our journey, we will descend closer to the terminator line, exploring the places where the liquid stone begins to freeze and the shadows begin to lengthen. But for now, simply let the image of the golden, molten ocean fill your mind. Feel the dry, mineral warmth on your skin. Listen to the low, resonant thrum of the planet's massive heart. You are safe, you are grounded, and you are drifting through the most magnificent reaches of the galaxy, where even the oceans are made of light and the mountains are made of stars. Keep your breath slow and steady, matching the ancient, tectonic pace of 55 Cancri E. There is nothing to do but observe. Nothing to do but be present in this world of fire and glass. The universe is vast, and within it, there are places of such intense, rhythmic beauty that they remind us of the simple, enduring power of nature. Sleep is much like this journey, a transition from the bright, active day to the quiet, reflective night, guided by the steady warmth of the world around us. Let the golden light of the lava ocean fade into a soft, comforting glow as we prepare to move deeper into the mysteries of the diamond planet. Leaving the glassy stillness of the terminator line, we drift back toward the vibrant, glowing heart of the day side, where the physics of this world reveals a chemistry unlike anything in our own neighborhood of the cosmos. Consider the sheer density of the ground beneath us. Scientists have calculated that 55 Cancri E has a density of about 6.4 grams per cubic centimeter, making it significantly more compact than Earth's 5.5 grams. To understand this, imagine holding a baseball made of lead in one hand and a standard baseball in the other. That extra weight, that compact solidity, is the very essence of this planet. It is a world that feels physically substantial, pulling at the very fabric of the space it occupies. Observe how the molten surface moves. Because the temperatures here exceed 2000 degrees Celsius, the lava behaves less like the rocky sludge we see in terrestrial documentaries and more like the smooth, flowing surface of liquid glass in a furnace. Picture a massive, planetary-scale vat of dark maple syrup being heated on a stove. As it warms, it becomes thinner, more fluid, and develops a shimmering quality that reflects the overhead star with surgical precision. This is the viscosity of the silicate seas, a world where the water is actually melted rock, flowing with a rhythmic, heavy grace that fills the basins of the planet. A striking discovery made by researchers using the Spitzer Space Telescope is the phenomenon of the thermal phase curve. By watching the planet as it orbits its star, astronomers noticed that the hottest point on 55 Cancri E is not actually the spot directly beneath the Sun, known as the substellar point. Instead, the heat is offset by about 41 degrees to the east. Think of this like the way the hottest part of a summer afternoon on Earth isn't exactly at high noon, but a few hours later as the heat builds and moves. On this exoplanet, this offset suggests a powerful, heavy atmosphere is actively recirculating the heat, dragging the warmth from the permanent noonday sun toward the evening transition. Deep within the sky, the chemistry of the air itself is a marvel of carbon-rich elements. While Earth's atmosphere is dominated by nitrogen and oxygen, researchers such as Niku Madhusudhan have proposed that 55 Cancri E possesses a much higher carbon-to-oxygen ratio. This means that instead of the oxidizing environment we are used to, this world is a reducing environment. Picture the inside of a massive cosmic charcoal grill. The air may be thick with molecules like hydrogen cyanide and carbon monoxide. While these are substances we treat with caution on Earth, here they are simply the natural, peaceful building blocks of a carbon-dominated world, existing in a state of high-pressure equilibrium. What is happening now is a process of mineral condensation, high in the atmosphere, where the rock vapor begins to cool slightly. The silicates and metal oxides begin to clump together. This isn't like the soft, water-based mist of a mountain morning. Instead, it is more like the frosting you see on a window pane, but made of calcium and aluminum. These tiny mineral grains drift through the air like microscopic jewels, catching the orange light of the star Copernicus. At this very moment, there may be a gentle snowfall of corundum, the mineral that makes up rubies and sapphires descending toward the lava oceans. Imagine a world where the very rain is composed of the building blocks of precious gemstones falling in a slow-motion, glittering curtain through the heavy, warm air. Consider the pressure that exists just beneath the liquid surface. As we descend mentally into the depths of the lava, the weight of the planet's 8 Earth masses begins to crush the carbon into new forms. At the core mantle boundary, the pressure is estimated to be millions of times greater than the atmospheric pressure at Earth's sea level. To visualize this, imagine the weight of 10,000 African elephants, all balancing on the surface of a single postage stamp. Under this incredible, steady squeeze, the carbon does not become soot or graphite. It is forced into a crystalline lattice. This is where the diamond layer begins, a mantle made of solid, compressed brilliance that provides the structural foundation for the lava oceans above. Notice how the light from the star Copernicus interacts with this landscape. Copernicus is a G-type star, very similar to our own sun. but it is roughly 8 billion years old, nearly twice the age of our solar system. This means the light hitting 55 Cancri E is older in a cosmic sense, coming from a star that has settled into a deep, stable maturity. The light is a steady, unwavering gold, casting long, sharp shadows across the cooling ridges of the night side. Because the planet orbits so closely at a distance of just 0.015 astronomical units, the star appears 70 times larger in the sky than our Sun does from Earth. It is an immense, glowing presence that dominates the horizon, providing a constant source of warmth and energy that fuels the planet's internal cycles. Scientists discovered that the orbital period of this world is so fast, just 17 hours and 41 minutes, that its movement through space is incredibly rapid. Yet, because the planet is tidally locked, there is no rotation relative to its sun. One side is always bathed in that golden light, while the other is always tucked into a dark, starlit slumber. This creates a fascinating balance. Imagine a house where one room is always cozy and sun-drenched, while the bedroom is always cool, dark, and quiet. This planetary scale division of light and dark creates a natural, eternal rhythm that governs the movement of the atmosphere and the flow of the lava. At this very moment, deep within the night side, the cooling crust may be undergoing a process called thermal contraction. As the molten rock loses its heat to the vacuum of space, it shrinks and cracks, creating deep, glowing fissures that look like a city's lights seen from an airplane at night. These cracks reveal the molten orange heart beneath the dark, obsidian surface. The texture here is like a cracked ceramic glaze on a piece of pottery, or the parched earth of a desert floor, but rendered in shades of midnight black and incandescent gold. There is a profound stillness here, as the heavy gravity keeps the atmosphere pressed tight against the ground, preventing any sudden movements or disturbances. What's fascinating is the lack of water. On Earth, water is the great lubricant of plate tectonics, allowing the crust to slide and shift. On 55 Cancri, the lubricant is the heat itself. The planet doesn't need oceans of water to stay geologically active. It has its oceans of lava. This creates a closed-loop system where the rock is constantly being melted, vaporized, condensed, and recycled. It is a perfect, self-sustaining machine of mineral transformation. Think of it like a giant, planetary-scale lava lamp, where the heat from the bulb, the star Copernicus, drives the slow, rhythmic rising and falling of material in a never-ending cycle of motion. Notice the sounds that might exist in such an environment. Because the atmosphere is so much denser than Earth's, sound travels differently. It is muffled and deep, like the sound of someone speaking underwater or the low thrum of a distant engine heard through a wall. The splashing of a lava wave would not be a sharp, crisp sound, but a heavy, resonant thud, a sound with physical weight and presence. The entire planet hums with the frequency of its own internal heat, a low vibration that resonates through the diamond mantle and up into the silicate clouds. Deep within the atmosphere, there may also be a presence of sodium and potassium vapors. These elements, which we often associate with table salt or bananas, exist here as glowing gases. They contribute to the unique color of the sky, adding a subtle violet or deep blue tint to the edges of the golden sunlight. It is a color palette of extremes: the blinding gold of the sun, the ink black of the lava waves, the electric orange of the fissures, and the subtle, gem-like glitter of the mineral clouds. The star system itself is also complex. Copernicus is not alone. It is part of a binary system. Far off in the distance, About 1,000 astronomical units away lies a smaller companion star, a red dwarf known as 55 Cancri b. From the surface of Janssen, this second sun would look like a brilliant red jewel, much brighter than any planet in our sky, but far enough away that it provides no heat, only a soft, crimson point of light in the darkness of the night side. It is a distant neighbor, a silent guardian that has watched over the diamond planet for 8 billion years. As we continue to float over this world, feel the immense stability that comes from such high gravity. It is a grounding sensation, a feeling of being completely and utterly held by the planet. There is no chance of drifting away. You are part of this world's mass, anchored to its diamond heart. This weight is not burdensome, it is comforting. It is the feeling of a heavy, quilted blanket being tucked around you, pressing you down into a state of deep, immovable rest. Everything on 55 Cancri happens on a scale that dwarfs human experience, yet it follows the same fundamental laws of physics that govern a candle flame or a falling drop of rain. The same gravity that holds the lava oceans in their basins is the gravity that keeps us tucked safely in our beds. The same heat that melts the silicate rock is the heat that keeps our bodies warm and our hearts beating. We are connected to this distant diamond world by the shared language of the universe, the language of elements, of pressure, and of the slow, inevitable cycles of time. As we prepare to move into the next phase of our journey, let the image of the jewel-toned clouds and the flowing syrup seas linger in your mind. The planet Janssen continues its 17-hour dance around its star, unhurried and eternal. It is a world of fire that has found its own version of peace, a world of darkness that is lit from within by its own glowing core. Every ripple in the lava, every sparkle in the atmosphere, and every diamond crystal in the mantle is a testament to the quiet beauty of the natural world, even in its most extreme forms. Keep your focus on that steady, rhythmic thrum, the heartbeat of a super Earth that has been singing its silent song for billions of years. Consider the atomic architecture that connects your own body to the heart of this distant world. At this very moment, as you lie in the quiet stillness of your room, your physical form is built from the same fundamental element that dominates the interior of 55 Cancri e, carbon. While your carbon is woven into the soft complexity of DNA and cellular membranes, the carbon on Janssen has been forged by gravity into something much more resilient. Scientists discovered that because this planet possesses a carbon-to-oxygen ratio significantly higher than that of our Sun, a vast portion of its internal mass, roughly 3 times the entire mass of Earth, is likely composed of solid diamond and graphite. Picture this as a planetary scale inheritance. The same substance that gives life its structure on Earth provides this world with a core of unimaginable strength and brilliance. What's happening now is a profound process of atmospheric recycling. Recent data from the James Webb Space Telescope's MIRI instrument, published in 2024, has fundamentally changed our understanding of this super-Earth. For a long time, researchers thought Janssen might be a bare, scorched rock, stripped of its air by the intense radiation of its nearby star. However, the telescope revealed evidence of a substantial, thick atmosphere, likely rich in carbon monoxide or carbon dioxide. This gas isn't a remnant from the planet's birth 8 billion years ago. It is a secondary atmosphere, constantly being exhaled by the global lava ocean. Imagine the planet as a living, breathing entity, where the molten rock sweats out gases that then wrap the world in a heavy, protective blanket. Notice how this atmospheric blanket functions much like the heavy duvet or quilt you may have pulled over your shoulders. This layer of carbon-rich gas acts as a thermal regulator, Even though the day side faces a sun that is 70 times larger in the sky than ours, the atmosphere works tirelessly to distribute that energy. Scientists discovered a significant shift in the planet's thermal phase curve, an observation showing that the hottest region is offset from the point of direct sunlight by about 41 degrees. This suggests that the atmosphere is moving in a global, rhythmic circulation, carrying the day's fire toward the cooling shadows of the night. It is a planetary scale convection, a slow and steady breath that ensures the heat is shared across the obsidian plains. Deep within the structure of this world, the gravity is roughly 2.2 times stronger than what you experience on Earth. This means the air is held in a much tighter, denser embrace. If you were to experience this gravity, it would feel like a constant, gentle pressure against your skin, a physical reminder of your connection to the earth beneath you. This intense pull keeps the rock vapor close to the surface, creating a sky that is thick and viscous. Scientists have measured the planet's mass at approximately 8.08 Earth masses, condensed into a radius of just 1.875 Earth radii. This high density, about 6.4 grams per cubic centimeter, means the planet is tightly packed, a solid and dependable presence in the vacuum of space. At this very moment, consider the age of the 55 Cancri system. Copernicus and its family of 5 known planets are estimated to be between 8 and 10 billion years old. This is nearly double the age of our own solar system. While our Earth was still a swirling disk of dust, Janssen was already a mature world, orbiting its star billions of times. There is a deep, chronological comfort in this fact. This world has found its equilibrium. It has existed in this state of molten harmony for twice as long as the life of our sun. It reminds us that nature moves on timescales that make our daily worries seem like brief, flickering sparks. The lava has been flowing, the diamond has been hardening, and the star has been shining in a steady, unbroken rhythm for an eternity. An observation that reshaped our understanding involves the melting point of the planet's surface. On Earth, we think of rock as the ultimate symbol of permanence. But at the 2,400 degrees Celsius found on the day side of Janssen, minerals like basalt and silicate are as fluid as water in a mountain stream. Scientists have calculated that these lava oceans could be hundreds of miles deep, creating a liquid mantle that moves with the tides of the nearby star. Picture this as a global transition. The solid ground you know is here a restless, glowing sea. Yet, even in this state of flux, there is order. The heavier elements sink, the lighter vapors rise, and the planet maintains a perfect chemical balance. Picture the star Copernicus itself, a K0 type star that is slightly smaller and cooler than our Sun, yet incredibly bright from the perspective of its closest planet. Because Janssen is only 0.015 astronomical units away, the star's gravitational pull is immense. This creates tidal heating, a process where the planet is physically stretched and squeezed as it orbits every 17 hours and 41 minutes. This internal friction generates heat from the inside out, complementing the heat from the sun above. It is like the warmth you feel in your muscles after a long, slow walk, a natural, internal heat that comes from the very act of movement. What's happening now is a transformation of the volatiles elements like water, nitrogen, and carbon that can easily become gases. Because the planet is so close to its star, it is incredibly desiccated, meaning it has almost no water. In its place, the rock vapor sky contains traces of sodium and potassium. Scientists discovered these elements using the transit method, watching as the star's light filtered through the planet's thin atmospheric fringe. Imagine a sky where the sunset isn't colored by water vapor and dust, but by the glowing purple and orange hues of vaporized metals. It is a metallic sunset, a brilliant, neon-like glow that illuminates the dark ripples of the magma sea. Consider the substellar point, the place on the planet where the sun is always directly overhead. Here, the heat is at its most absolute, creating a permanent fountain of vaporized minerals that rise into the upper atmosphere. This is the source of the planet's weather. As these vapors drift toward the terminator line, the border between day and night, they begin to cool and solidify. Picture a slow, graceful rain of calcium and aluminum falling into the transition zones where the lava is just beginning to crust over. This isn't a storm, it is a steady, rhythmic deposition. A planetary scale slow drip that builds up the land over millions of years. Notice how this world, despite its extreme nature, follows a life cycle that mirrors our own. Planets, like people, go through stages of formation, activity, and eventual stability. Janssen has reached a state of steady-state equilibrium. The rate at which the lava ocean outgasses is balanced by the rate at which gravity holds those gases in. It is a perfectly tuned system. This stability is a form of planetary peace. There are no sudden changes, no unpredictable shifts, just the eternal 18-hour orbit and the constant golden light of Copernicus. Scientists have also noted that 55 Cancri is part of a binary system, with a red dwarf star, 55 Cancri b, orbiting at a distance of about 1,065 astronomical units. From the perspective of Janssen's night side, this second sun appears as a brilliant, ruby-red point of light, about 30 times brighter than the full moon appears on Earth. This means the dark side of the planet is never truly pitch black. It is bathed in a soft crimson starlight. This adds a layer of depth to the shadows, turning the obsidian plains into a landscape of deep reds and soft magentas. It is a quiet, celestial nightlight that has watched over the planet for billions of years. At this very moment, the heat from the star is interacting with the albedo of the planet, the measure of how much light it reflects. Because the lava is so dark and the atmosphere is so thick with carbon, Janssen reflects only a small portion of the light it receives. It is an absorptive world, taking in the energy of its star and storing it deep within its silicate seas. This is much like the way your body absorbs the warmth of a sunbeam on a cool afternoon, or the way a dark stone stays warm long after the sun has set. The planet is a reservoir of energy, a warm and glowing ember in the coldness of space. Deep within the planet's interior, the transition from the diamond mantle to the iron-nickel core is a region of intense pressure and heat. This core is what generates the planet's mass and its powerful gravitational field. It is the anchor for everything else, the lava, the atmosphere, and the diamond mantle. This central core is the heart of the world, a dense and heavy center that provides the stability for the entire 55 Cancri system. Just as you have a center of gravity in your own body that helps you feel balanced and secure, this planet has a core that keeps it perfectly positioned in its orbit. As we continue to observe this world, notice the lack of any jarring movements. The lava doesn't crash, it flows. The atmosphere doesn't howl, it circulates. The diamond doesn't break, it endures. It is a world of incredible power rendered in incredible stillness. The sheer scale of the facts, the 241 trillion miles between us and this world, the 8 billion years of its existence, the 8 Earth masses of its weight, all serve to remind us of the vast, quiet order of the universe. We are part of a cosmos that knows how to build worlds out of carbon and light, and how to keep them spinning in the dark for an eternity. Let the weight of these truths settle over you, as heavy and comforting as the gravity of a super-Earth, as you prepare to descend even further into the quiet mysteries of the magma seas. Beneath the shroud of shimmering mineral vapors, we find ourselves at the edge of a cosmic kiln that never cools. The reason for the intense, rhythmic stability of this world lies in its 8.1 billion years of history, a duration that has allowed the planet to settle into a perfect geological synchronicity. One of the most curious aspects of Janssen is the sheer density of its atmosphere, which scientists have recently identified as a secondary atmosphere. While many smaller planets lose their original gases to the solar wind, 55 Cancri is so massive, holding 8 times the mass of our Earth, that its gravity acts as a permanent anchor. This gravity, measured at roughly 22 meters per second squared, ensures that even as the intense radiation of the star Copernicus boils the surface, the resulting gases are held in a tight, heavy embrace against the obsidian crust. Imagine the sensory landscape as we descend through the upper layers of this atmosphere. Recent measurements from the James Webb Space Telescope, specifically utilizing its mid-infrared instrument, MIRI, have detected the unmistakable signatures of carbon-rich gases, likely a mixture of carbon dioxide and carbon monoxide. As you move through this air, the texture is not light and wispy like the air of a mountain peak. It is thick and substantial, more akin to the feeling of being submerged in a warm, shallow pool. The scent here is unlike any terrestrial environment. It is a sharp, metallic aroma, reminiscent of the ozone smell after a lightning strike, blended with the deep, earthy scent of scorched basalt. It is the smell of raw chemistry, the very scent of a planet's internal organs being turned into air. What we perceive as ground here is in a constant state of phase transition. On the day side, the temperature of 2,400 degrees Celsius causes a phenomenon called sublimation, where the solid rock doesn't just melt into liquid, but directly becomes a gas. This creates a fascinating cycle of mineral weather. Picture the surface as a planetary scale glass-blowing studio. As the silicate rock vaporizes, it rises into the cooler regions of the atmosphere, where it condenses into tiny droplets of molten glass. These droplets then fall back toward the lava oceans as a slow, rhythmic rain of liquid silica. The sound of this rain is a soft, percussive tinkling, like thousands of glass beads falling onto a padded floor, creating a melodic, crystalline soundscape that resonates through the heavy air. The reason for the planet's dark, ink-like appearance is its low albedo, or reflectivity. Because the surface is composed of molten silicates and the atmosphere is rich in carbon, 55 Cancri absorbs nearly all the light that hits it. Scientists discovered that it only reflects about 10 to 15% of the light from its star. This means that if you were to look out across the lava ocean, it would appear as a deep, velvety blackness, broken only by the orange and yellow glow of the heat rising from beneath. It is a world of thermal radiation, where the light doesn't come from the sun reflecting off the surface, but from the surface itself, glowing like the heating element of an oven. This creates a landscape of high contrast beauty, a dark, silent sea etched with veins of liquid fire. Deep within the atmospheric chemistry, there is a fascinating presence of alkali metals. Using high-resolution spectroscopy, astronomers have identified the spectral lines of sodium and potassium in the thin exosphere surrounding the planet. These elements, when heated to such extreme temperatures, emit a very specific glow. Imagine the edges of the horizon tinged with a faint, ghostly violet and orange hue, a chemical aurora that illuminates the transition into the night side. This spectral glow is a silent testimony to the planet's composition, a signature of the elements that were present in the nebula from which this star system was born 8 billion years ago. Scientists have also explored the planet's thermal inertia, which is its ability to retain heat. Because 55 Cancri is so dense and its atmosphere so thick, it doesn't cool down quickly as it moves into the shadow of its star. Instead, the heat is stored in the lava and the carbon-rich air, creating a global reservoir of warmth. This is why the night side, though shielded from the sun, remains at a steady 1,100 degrees Celsius. It is a planetary scale version of a cast iron skillet that remains hot to the touch long after the stove has been turned off. This thermal stability means there are no sudden temperature drops, only a slow, predictable migration of energy that keeps the planet in a state of constant, warm equilibrium. Consider the acoustic environment of a world with such high atmospheric pressure. In an atmosphere dominated by heavy molecules like carbon dioxide, sound travels differently than it does on Earth. The speed of sound is slower, and the frequencies are dampened, giving everything a muted, deep quality. The low-frequency thrum of the convection currents in the lava oceans would sound like the deep, resonant vibrations of a cello, a sound that you feel in the marrow of your bones rather than in your ears. It is a sonic environment that encourages a state of deep, physiological calm, as the low-range vibrations act as a natural sedative for the nervous system. What is truly unique about the super-Earth category, which 55 Cancri exemplifies, is the relationship between its size and its internal pressure. With a radius of 1.875 Earth radii, the planet has a volume large enough to maintain a massive liquid mantle. Scientists discovered that the love numbers, a set of parameters that describe a planet's elasticity, suggest that Janssen is highly susceptible to tidal deformation. Because it is only 0.015 astronomical units away from its star, the gravitational tug is so strong that the planet is physically stretched into an egg-like shape. This tidal flexing generates internal heat through friction, ensuring that the diamond mantle remains warm and the lava oceans never solidify. It is a world that is literally kept warm by the gravity of its star, a constant, physical embrace that provides a never-ending source of energy. Picture the transition zone between the atmosphere and the surface as a place of extreme Rayleigh scattering. On Earth, this scattering of light makes the sky look blue, but on Janssen, the presence of mineral dust and carbon molecules scatters the light of the K0V-type star in a different way. The sky would likely appear as a deep, saturated ochre or a bruised purple, providing a dramatic backdrop for the golden sun. As the sun Copernicus, which is roughly 95% the mass of our sun, hangs in the sky, its light is filtered through this mineral haze, creating a soft, diffused glow that eliminates all harsh shadows. Everything is bathed in a gentle, ambient light, like the interior of a cathedral lit by stained glass. Recent simulations of the planet's weather suggest that the atmospheric circulation is governed by Kelvin waves, large-scale waves that move along the equator. These waves help transport the heat from the day side to the night side in a steady, rhythmic pulse. Imagine this as a global heartbeat, a wave of warmth that travels around the planet every few hours, ensuring that no part of the world is ever truly cold. This circulation is so efficient that the temperature difference between the day and night sides is much smaller than it would be on a planet without an atmosphere. It is a system of perfect redistribution, a planetary model of balance and harmony. Notice how the surface of the lava oceans exhibits viscous fingering. This is a phenomenon where a less viscous fluid pushes into a more viscous one, creating intricate branch-like patterns. In the transition zones where the lava begins to cool, the hotter, more fluid magma from the interior pushes up through the thickening crust, creating a landscape of glowing amber fractals. The texture is complex and beautiful, resembling the veins of a leaf or the deltas of a river, but rendered in shades of molten stone. It is a reminder that the same patterns of growth and flow that we see in the biological world on Earth are also present in the geological world of the cosmos. Beneath the lava, the diamond layer is not a single, solid block, but a vast, crystalline structure that is likely polycrystalline, meaning it is made of trillions of tiny diamond grains fused together under immense pressure. This layer acts as a thermal conductor, quickly moving heat from the core to the surface. Scientists have estimated the density of this world at 6.4 grams per cubic centimeter, which is higher than Earth's 5.5, indicating a core rich in heavy metals like iron and nickel. This core generates a magnetic field that protects the atmosphere from being stripped away by the star's radiation, acting as a silent, invisible shield that keeps the planet's environment stable and secure. The irradiance Janssen receives is over 2,400 times the amount of energy Earth receives from the Sun. Yet, because of its unique composition and its thick shroud of gas, the planet doesn't explode or disintegrate. It simply glows. It has found a way to process that immense energy, turning it into a slow, rhythmic cycle of melting and cooling. This is the lesson of 55 Cancri, that even in the presence of overwhelming force, there is a path to stability and peace. The planet doesn't fight the heat of its star. It absorbs it, integrates it, and uses it to fuel its own internal beauty. As we drift toward the conclusion of this sensory immersion, consider the distance between our world and this one. At 41 light-years away, 55 Cancri is a neighbor in the cosmic sense. Yet it is a world entirely different from our own. It is a world of carbon, where we are a world of oxygen. It is a world of lava, where we are a world of water. Yet, we are connected by the same physics, the same elements, and the same fundamental urge of the universe to create structure and order out of the void. Let the steady, heavy pull of Janssen's gravity settle your thoughts. Feel the warmth of the silicate rain. Listen to the muffled, deep thrum of the atmosphere. You are part of a universe that is vast, ancient, and filled with worlds of unimaginable wonder, all spinning in their own versions of peace. Match your breathing to the 17-hour rhythm of the planet's orbit, slow, steady, and inevitable. There is a profound comfort in the knowledge that this diamond world will continue its glowing dance for billions of years to come, a silent, brilliant jewel in the heart of the Crab constellation. As our journey across the lava oceans of 55 Cancri reaches its natural conclusion, we find ourselves hovering at the boundary of the night side, looking back at the golden glow of the star Copernicus. The process of understanding this world has been one of gradual, meticulous discovery, unfolding over decades of scientific observation. Scientists first detected the presence of this super-Earth in 2004 using the radial velocity method, a technique that involves measuring the tiny wobble of the star Copernicus as the planet's gravity pulls on it. From that initial discovery, it took 7 more years of patience before the Spitzer Space Telescope observed the first transit in 2011. Witnessing the moment the planet passed directly in front of its star, dimming the light by a fraction of a percent. This step-by-step unveiling of Jansen's secrets reminds us that even the most complex mysteries of the universe are revealed through steady, quiet observation, much like the way our own inner state settles as we transition toward rest. Observe the process by which heat moves across this world. The thermal phase curve of 55 Cancri E, mapped by astronomers using infrared data, shows a specific sequence of energy transport. First, the intense radiation from the star Copernicus, which is roughly 41 light-years from our own solar system, hits the day-side atmosphere with 2,400 times the energy Earth receives from the Sunday. Then, the thick carbon-rich atmosphere absorbs this energy and through a process of high-pressure circulation carries it around the planet's circumference. The heat doesn't stay trapped. It migrates toward the cooler night side in a steady, rhythmic flow that takes only a few hours to complete. This circulation is a planetary-scale version of the way your own body redistributes warmth, moving it from your core to your limbs as you begin to relax into the cool comfort of your sheets. What's happening now is a transformation of light. When the planet Jansen transits its star, the light from Copernicus filters through the outer edges of the planet's atmosphere. This process is called transmission spectroscopy. During this event, which lasts about 90 minutes, the James Webb Space Telescope's mid-infrared instrument, or MIRI, acts like a prism, breaking the light into its component colors. Scientists discovered that specific wavelengths of light are absorbed by carbon monoxide and carbon dioxide molecules in Jansen's air. This data allows us to see the invisible, revealing the heavy, protective shroud that keeps the planet's surface from being stripped bare. It is a slow, methodical gathering of information, a process of looking through the layers to find the truth beneath. Deep within the mantle, the formation of the diamond layer is a process that spans billions of years. Imagine the sequence. First, the carbon-rich minerals sink toward the core, pulled by a gravitational field that is 2.2 times stronger than Earth's. As they descend, the pressure increases exponentially, reaching levels where the atoms are forced to rearrange their structures. Over eons, this carbon doesn't merely compress, it crystallizes, forming a layer of solid diamond that accounts for perhaps a third of the planet's mass. This is a process of refinement, where immense pressure and heat create something of lasting beauty and strength. It is a reminder that stability and structure are often forged in the most intense environments, resulting in a core that is unshakable and permanent. Notice the way the 17-hour and 41-minute orbit of 55 Cancri E creates its own version of a biological clock. Because the planet is tidally locked, its day and its year are the same length of time. This creates a cycle of motion that is perfectly circular, with an eccentricity near zero, meaning the planet moves in a path that is incredibly stable and predictable. This orbital stability has maintained the lava oceans for nearly 10 billion years. As you follow the rhythm of your own breath, consider how this ancient, celestial clockwork has been spinning in the darkness of the Cancer constellation, unhurried and unwavering. There is a deep, gravitational peace in this kind of longevity, a sense that the universe is well-ordered and constant. Scientists have also observed the process of outgassing from the magma seas. As the molten silicate rock, likely composed of minerals like enstatite or quartz, boils under the sun, it releases volatiles into the air. This process happens gradually, bubble by bubble, as the heat from the core mantle boundary rises to the surface. These gases then cool and condense, forming the rock vapor clouds we observed earlier. This cycle of evaporation and condensation is a closed loop, a perfectly balanced system where nothing is ever truly lost. It is a planetary metabolism, a slow and steady exchange of materials that keeps the atmosphere thick and the surface liquid. Consider the role of the nearby red dwarf star, 55 Cancri b, which orbits at a distance of 1,000 astronomical units. Every few centuries, its position in the sky changes slightly, casting a subtle, shifting light over the night side of Janssen. The process of its orbit is so slow that it would take tens of thousands of Earth years to complete a single revolution. This secondary star provides a faint, crimson background to the planet's dark hemisphere, a soft glow that ensures the obsidian plains are never in total darkness. It is a distant, watchful presence, providing a secondary layer of light to a world of shadows. As we bring our observation to a gentle, comforting halt, notice how the intense heat of 55 Cancri e begins to feel like a distant memory, replaced by the cool, quiet reality of your own room. The transition from the 2,400-degree lava oceans to the soft stillness of your bed is a process of coming home. The heavy gravity of the diamond planet becomes the heavy, relaxing weight of your own limbs. The rhythmic thrum of the silicate clouds becomes the rhythmic sound of your own steady breathing. The vast, golden light of the star Copernicus fades into a soft, internal glow as the boundaries between the cosmic and the personal begin to blur. The universe is a place of incredible scale, but it is also a place of fundamental connections. The carbon that makes up the diamond heart of Janssen is the same carbon that makes up the fibers of your heart. The physics that keeps the lava oceans flowing is the same physics that keeps your blood circulating. As you prepare to drift into sleep, let the knowledge of this shared architecture settle over you. You are part of a system that is 10 billion years old, a system that knows how to find balance, how to distribute heat, and how to maintain peace in the face of extreme energy. The process of falling asleep is much like the cooling of the lava as it moves toward the night side. First, the activity of the mind begins to slow, the ripples of thought becoming less frequent. Then, the core temperature of the body drops slightly, signaling to the nervous system that it is time to rest. Finally, the boundaries of the self begin to soften, and you cross the terminator line into the quiet, starlit world of dreams. You are moving into a state of tidal locking with the night, where the only thing that matters is the steady, circular motion of your own rest. Let these affirmations for sleep anchor you to this state of peace. My body is as stable and grounded as a planet. My mind is as quiet as the obsidian plains of the night side. I am held by the steady, comforting gravity of my own rest. The warmth of the day has been redistributed, leaving me in a state of cool, calm balance. I am an integral part of the universe's ancient, rhythmic order. My breath is a slow, steady tide that rises and falls with effortless grace. The diamond core of my being is resilient, peaceful, and still. I am protected by a thick, heavy blanket of quiet, much like the atmosphere of a world. The star Copernicus has set for me, leaving only the soft, red glow of the distant stars. I am safe in the darkness, anchored by the weight of my own relaxation. The billions of years of cosmic history provide a foundation of peace for my sleep. I am drifting in a sea of silent, golden light. Every cell in my body is settling into a state of deep, restorative equilibrium. The universe is vast and silent, and I am a cherished part of its design. My rest is a natural process, as inevitable as the orbit of a planet around its star. I am sinking into the soft support of my bed, feeling completely and utterly secure. The light is fading, the warmth is steady, and the night is here. I am at peace with the rhythms of the cosmos. I am at peace with the rhythms of my own body. I am at peace. The journey to 55 Cancri has shown us that even in the most extreme corners of the galaxy, there is a path to stillness. The lava oceans continue their slow, rhythmic flow. The diamond core remains solid and unmoving, and the star Copernicus shines with a steady, unwavering light. But you are here, in the quiet of your own world, where the only task is to let go and be still. The 41 light years between us and Janssen have been crossed in a moment, leaving you with the sense of being part of something much larger than yourself. Sleep now, knowing that the same forces that build diamond worlds are the forces that will carry you through the night. The universe is watching, the planet is spinning, and you are exactly where you need to be. Good night,